Okay, in this tutorial I'll try and clear up some ambiguities that might exist when working with these trigonometric functions, the sine and the cosine, and in particular with angles that are not over in this location here. So in this section up in here, we usually call this, I'll just write this in, quadrant. So I'll just call it Q1, like this. So angles that are over in this region, like here, and angles that are in this little region up in here, I just call Q2. So quadrant 2, and then it goes around the circle over here is quadrant 3, and here's quadrant 4. So these are just good things to know reference wise, because they'll show up a lot. All right, because now say for instance when we were working with these sine and cosines of these angles in degrees or radian mode, it would give you, your x and y value. And the reason it's a y value for sine, I mentioned this in an earlier lesson. In the case it's the y value for the sine only happens to be because this particular triangle is oriented that the opposite side of the triangle is oriented with the y-axis. If your triangle was turned at 90 degrees, and this is just really worth repeating, if you had a triangle that would look like this and the 90-degree angle was up here in this corner like this, then this is your opposite side over here like that, but that would also now become the sine because it's the opposite side. It's always opposite of this angle like this is the sine, and always adjacent to the angle is the cosine like that. That's how those are typically referred to. You can actually just say, this is the sine and this is the cosine like this. And another routine we'll look at in the future is the tangent. The tangent you'll see as a function, we won't deal with that right now, but you'll see the tangent is equal to the opposite over the adjacent like this, ADJ, but you also see it like this. You'll see tangent is equal to the sine over the cosine. Alright, so it's a good thing to always associate that opposite side with the sine and the adjacent side with the cosine, like this. Alright, so that's one thing. But the other thing is, the reason we're doing it is when you take, say, the cosine of 45-degree angle of this unit circle here, so radius of 1, it's going to provide you an answer of 0.707. It's a positive value. Right, but if we had a different triangle, say a triangle that was coming out here like this to the center, and say your triangle started from here and went all the way around here, which would be like a 135-degree angle, or the same as for those of you who use radians like I like to use, that would be 3/4 of the way to pi angle-wise, so that would be just basically 3/4 pi. Alright, that's the same angle as 135 degrees. But if you were to take the cosine of 135 degrees, in fact I'll just show you on the regular calculator, 135 cosine, it gives you negative value. Alright, so it gives you negative 0.707 for this x component. Well, but I'm trying to tell you that this is also a length. What is the length of 0.707? And this length, if you had a triangle over here, it would look like this. Well, obviously this has a length of 0.707, but the calculator says it's negative 0.707. And that's because when you see a negative value like that, like a negative 0.7071, it really is referring to a direction. So this is a direction in the positive x direction, and when you see negatives, it's directions in the negative x direction, like that. So that's really becomes important because as we get up into higher dimensions of math, when we use three-dimensional coordinates x, y, and z, always these reference values refer to directions as well, whether it's positive or negative. So you know which way, for instance, maybe we'll be getting into vectors, and a vector points in a certain direction in x, y, and z. Well, my vector has to be indicated in a positive or a negative way, so I know which way it's actually pointing. You see those negative angles, that's what that means. It still means it's 0.707, but in the negative direction on that axis. Alright, so let me clear this stuff just for a second. Yeah, one other thing in here, and that is about negative angles I haven't addressed yet. So negative angles are normally, when we're dealing with this, we're talking about pi over 2, as this is your angle up here, pi over 2 in radians. you don't always enter in values all the way around the circle in a positive direction. Sometimes you enter them, this is 0 over here. This angle, if your angle is going this direction like this, you would specify your angle as negative pi over 2. And this angle would be, negative 45 degrees. It would be negative pi over 4, like that. And this up here would be pi over 4, like this. All right, so that's important to know, and in particular, in the next lesson, I'm going to show you why we need to take advantage of that within Blender. So the power of using Blender is that we can use the mathematics and we can design cool graphics at the same time. And we'll go well beyond that. In fact, I'll have a lot of intermediate and advanced tutorials on my Sci-Fi Animator website, and they're going to be paid tutorials, not terribly pricey, but what they do require is your knowledge of mathematics. Since I'm geared towards teaching technical artists how to use 3D and 2D programs. Well, math is just an integral requirement as far as all that's concerned. So you have to be super well grounded in mathematics to be able to take advantage of a number of the tutorials that I'll have on my website. So that's why these lessons are important. Alright, so in the next lesson we're going to draw these triangles around the circle, and I'm going to show you why these negative angles in radians make a critical difference. Alright, well that's it for now, and I'll see you in the next video.